Okay, hello. Happy Monday.
Afternoon.
Okay, 49 of us in class 14 here. I'm going to put out an announcement and make sure people are keeping up with this stuff. And let's get going here. Oh gosh, I got a couple things I got to do here. Let's see that there, and we're in here, and we're here. All right. So we are here in week 3, and I'm about a week behind because I wanted to introduce project ideas last week. Excuse me, I'm going to sneeze. And then team formation this week, that's on track. And then next week, once you have your teams formed, which will be this week, then next week you do your team product definitions. And so we'll talk more about what the project requires, and I'll have the actual project assignments up then. And then once you get done with the product definitions, which will have some deliverables associated with them, then you go into product development, and we do that through 5 sprints. And those of you that have taken CS 225 with me, hopefully we'll have an idea of what I mean by a product sprint, but that's what this lecture is all about. So we're working with the Agile software development process here, and we'll talk at great length about that. And the idea is you develop your code in these short little bursts of time called sprints. At the end of each sprint, you have working code. And then at the end of the next sprint, you have working code with more functionality. And then you just keep adding functionality piece by piece to the code. But the point is, even at the end of the very first sprint, let's say by the second sprint, you have working code. Sometimes the first sprint is really devoted to organizing all of the goals of the project, but I think we're basically going to treat week 4 as that. So you can actually do product development every time in your sprints. So what that means is I've been pretty hands-off and lazy on the course, which means you guys get to be hands-off and lazy on the course for the first 2 weeks. But once you get into your teams, I am not having, as you can tell, a lot of interaction with you in terms of lecture time, because I want you to have a lot of interaction and activity with your teams. That's the goal. So it's a 4-credit course. You should be expecting to spend a fair amount of time on this course, but I don't want you to spend it listening to me. I want you to spend it actually doing work. And then along the way, I and the tutors will be there to provide guidance. Each team I'll assign, we should have 12 teams, and I'll give each tutor 6 teams, and then they're going to be your advisors, help you with the process, and help you with any workarounds that you need to get to. I think in terms of Agile, we're going to treat them as your customer, so that they become the person who ultimately will set goals for you. It's kind of a perverted system in academia, because normally you have an external customer and then they tell you what they want. And here you have teams that you're kind of your own customer because you're coming up with your own product idea. Okay, so after, by the end of this week, my expectation is that your activity level goes up. That doesn't mean that you and I do a lot more interaction like this. It means that you're going to be meeting with your teams, working with your teams, trying to figure out how to get the job done. So are there questions, first of all, about that?
Professor, I have a question about some students, like I do, have them take this course because of the minor. So is there gonna be like a grouping where the minor gonna be with like a major that support the minor, or just treat everyone equally?
Yeah, so one of the reasons that I create the teams instead of having the students self-form is you can get really unbalanced teams if it's self-formed. So instead I create the teams. I know most of you, I've had most of you before, so I have a pretty good idea of your capabilities and work habits, let's say. But what I want to do is make sure that each team is as balanced as possible, meaning there are some people that I would expect are fairly strong in software development, at least one person, and at least one person who is like taking this as a minor and maybe hasn't had that much experience in software development on the same team, so that you can learn from a more experienced person and then contribute more to the team as time goes on. And quite frankly, the person who thinks they know all about software development will learn from you too, because you're going to come in with a different point of view.
Thank you.
Does that answer the question?
Yes.
Okay. And to that end, I put up a survey. Where is it? Quizzes. I put up a survey, a project team survey. It's 5 questions. So answer those questions, and they're basically giving me better information about your background. In terms of your major, I can get that off of the, the standard material that they give me about the students. And again, I've already had a bunch of you in a previous class or classes, so I have a sense for how you ended up in those courses. Let's see. The trick here is to fill out the survey. Don't worry, I won't share your information with anybody. It's not anonymous because I need to know who you are, but that's just for me, the team survey. By the end of this week, I'll start posting all the actual definitions of what the project looks like, but we'll talk about it in this module. Now, this module talks about the Agile development process in general, then talks about Agile Scrum. Then we'll talk about Agile Scrum in the context of our class, and then talk about teams. And it's a 2-week, as you can see from the thing, it's actually a 2-week module. So we're not going to get through all the notes today. If we tried to, you'd all be asleep if you're not already. I haven't done the pre-recorded lectures yet for module 2, so I'll be doing those also during the week and getting them up. But obviously, these are repeating the material and sometimes enhancing the material that's in the pre-recorded lectures. All the notes are up there, so we're fine. And on Wednesday, as usual, I'll have office hours. Now, there's a quiz for module 2 up there, but next week I'll have a second quiz for module 2, because the first quiz is only about the first half of the material. So every week, you get to complete a short quiz that's basically, hey, are you paying attention kind of quiz. Once we get the teams assigned and I assign the tutors to the teams, I'm going to reach out to them to make sure that they're interactive with you. If your team is not working together in a way that's actually going to help produce the product, then I'm going to first rely on the tutors to try to work with you. I can't manage 12 teams. That won't work. And it's very difficult to manage 12 teams in an online environment. So break it down 6 and 6. And then each team will have a discussion page, and I really want you guys to use that because that's one way I get visibility into what's going on. I have no problem with you using external tools, but I don't have as much visibility into that, so I need a lot of that stuff echoed back on the Canvas page so I have documentation and can see what's going on inside your group. A lot of this class is about trying to work with group dynamics and team dynamics and try to help you guys find a way to apply the Agile processes in a way that makes sense for your group. Yeah. I'm going to talk a lot about the Agile Scrum process, and it's going to sound very rigid, and we'll do it in a fairly rigid way because I'm prescribing it, which of course is the opposite of Agile. Basically, what I'm going to do is give you activities and deliverables that you have to demonstrate to me that you're doing, but then you get to be flexible in how your team actually makes that happen. So some teams, you know, in an ideal Agile world, you meet every day, short meeting, 10-minute, 15-minute meeting tops. But that may not work for your teams. You know, some teams may only be able to meet twice a week or something like that. Well, you're probably going to have to adapt how you deal with those meetings. I'm on a faculty team of 4. We're working on an Agile process. We initially started out with, 2 short meetings a week because that's all we could fit in our schedule. And we ended up still only having 2 meetings a week, but we made them, one was an hour long and one was a short one. And we found that we just got a lot more work done when we had that hour-long meeting because it was a working meeting. Okay. I inherited these notes. I'm not thrilled with them. They're pretty good. I may put up another version of them, but more likely what I'm going to do is I absolutely, by the end of next week, will have some slides up that really summarizes how the process will work for our team. Here's the phases of a sprint. Here's what you need to do at the beginning, in the middle, and the end, and here's who does it, and here's the things that you should have, the artifacts that show that it was done. It's still following the Agile process. The only thing we're going to add to the Agile process, which is, well, we'll talk about this, where it's fairly light on documentation, is a requirements document and a design document, which some Agile processes absolutely don't have. Okay, there's a lot of terminology here. It may take a little bit of time to get used to the terminology, but that's why I want to have that summary sheet so you get a nice cheat sheet of what's happening. Okay, there's 4 parts to these notes, and my goal is to cover the first 2 parts this week, and then the next 2 parts next week. So that's why it's a 2-week module. I want you to get a little bit of time getting accustomed to the idea of the Agile process. And again, those of you that took CS 225 with me, you kind of followed an Agile process in that class, even though you were working as an individual. You did develop your code in sprints, and I did have you do user stories and had you track how your user stories got completed. So there was a kind of the idea of a burn down chart there, you know, a progress scorecard. Agile. Now, why Agile? Where did this come from? Mentally quick, an agile mind, speed of operations within an organization. Trying to be agile means being quick and responsive. That was the goal. And it's worked pretty well. I mean, this is the hot, raging, everybody's doing it fad right now, as everybody's doing agile. And that's kind of a testimony to its success. 20 years from now, I don't think people will be doing agile. That's just how the world works. 20 years from now, something else will take agile's place. Maybe it'll be super agile or something. I don't know. But where did it come from? Here's the core problem, and this is the thing to keep in mind all the time, because this is the core problem. As you go through a product development, things change. Now, we're going to do a fairly short product development time, right? You're in 1 semester, 14 weeks. Of that, only really 10 weeks is your development time. Not that much opportunity for change, but you're going to see enough changes in then. But, you know, if you have a normal product development that's, 9 months, 16 months, 2 years, something like that, over time, things change. And some of the things that changes are your customers' expectations of what they want you to do. And other things that change are you find out that something you thought was going to work doesn't work, which I quite frankly hope you experience during this class, so you get experience with recovering from those situations. You thought this would be great, doesn't work. Oh, we got to go back to the drawing board and figure something else out. So requirements change and solutions change based on test results and not passing test results. Personnel changes. People leave the company that you thought, we've got this great person who's great at software architecture, best designer in the world, and well, what do you know? The best designer in the world just got hired by somebody else, and now you have a team issue. So there's two ways to try to manage change. One way is to try to nail everything down so that it can't change. And that was the way that was tried within engineering since the beginning of engineering. And for a lot of engineering, that works out just fine. Particularly, again, engineering where you have physical parts. It works pretty well. But remember the essential issues that Fred Brooks talked about with software engineering. Some of this is changeability, invisibility. And what did changeability mean? Oh, it keeps changing all the time. Yeah, the customer will keep changing all the time. Hey, while you're doing that, do you mind if it also does this? Do you mind that it also does that? Or I don't want that anymore. I want you to do this instead. It's just software. How hard could it be? That's the mindset. So the way people tried to deal with change initially for 30, 40, 50 years was to nail it down. You had to document everything. You had to, every time the code, one line of code was changed, you had to go to a document and annotate that. And then that document interfaced with other documents. So now that change had to be rippled effect through. Or you got your software design and it's all documented, big, thick documents, all documented. And then you go into software test and you fail a test, so you have to redesign portions of the software. Now you're going to go back and change all these documents. And the problem is there's too much complexity there. So number one, when you make a change and now you have this giant document trail. So you make a change and you have to change all these documents. That's very costly, number one. Number two, it usually, or I shouldn't say usually, it often didn't happen. You changed the code, you didn't change the document, or you did change this document, but since that code was referenced in 8 other documents, you didn't change the other 8. Now the documentation, not only is it costly and time consuming and confusing, it's wrong. It doesn't even describe the software anymore. So you can see the problem. People tried to nail down change so it couldn't happen, but guess what? Change is smarter than us, and it happened anyway. So this approach takes the exact opposite point of view. It says change is going to happen, so don't lock yourself in up front. Don't have big, long documentation trails to try to avoid change and manage change. Instead, just go with it. You know change is going to happen. So why don't you produce your software in such a way that when the change occurs, you can basically embrace it rather than try to kill it. And so the net result of that is you can work in smaller teams, because in addition to the programming, the coding people, the software design people, you don't need that whole big tail of documentation kind of people. You have smaller teams, smaller documentation paths, and anytime you do less work, that means cheaper and faster. So your product was coming out cheaper and faster. Oh, and since it was agile, then you were responding to changes as they came up. So there were a couple aspects of that. And one of them was working with the customer as you went along. Instead of the customer saying, hey, here's what I want you to do, signs the contract, I'll be back in a year to pick up my software. You interact constantly with the customer, so that as change occurs, you can negotiate that in real time or provide the customer with expectations in real time. That's the goal. That's the goal. So that's the top level view of what we're trying to do here. Now, how do you do it? Oh, okay, and this is another definition of Agile methods. You do it through this iterative and incremental approach, this notion of sprints, right? So you have a rough idea of the software architecture. You don't have a complete design. You don't have everything nailed down yet. You have a good idea of where you're going to go, and then you build out the software bit by bit. And if you need to change where you thought you were going to go or what you thought the architecture was going to look like, to some degree, you can't start over from scratch necessarily, then you can accept that change within the system. Now, pay attention to these words, incremental and evolutionary. That's what these sprints are. So it used to be more along the lines of, we get all the software requirements, we get all the software design, we build all the software, we test all the software, a classic engineering technique. Now it's, we have an idea of where we're going, we get all the requirements up front, and then we start to develop tasks, and then we complete a couple tasks and test, and then go back to the customer and say, hey, are we on the right track? So this iterative and incremental, it's evolutionary, because as you learn more about the product by building it, you may learn that some of your initial assumptions were no good, or some things that you had as requirements from the customer previously probably weren't optimal. So you're developing this in a incremental approach. And then it says in a highly collaborative manner. Now, what does highly collaborative mean? Let's see. What does collaboration mean?
Working together. That's
yeah, exactly. You're working together, right? Now they say highly collaborative. That has no definition. So let's throw some definitions on it. Who are you collaborating with? Well, first of all, the team, the software team is highly collaborative. So the idea behind Agile is you have relatively small teams, like you guys are going to have teams of 4, and you might have 4 to 9 people, let's say, on a team. And they all, this is surprisingly important. They all sit in the same room. Again, going against the standard engineering approach of, so-and-so is in this room, so-and-so is in that room, so-and-so is in that room. And the reason they're separated because they were doing separate jobs. Like when I was in engineering, I did structural analysis. The designers were at the drawing tables over here. The contracts people were over there. The thermal analysis people were over there. And we all were in our little stovepipes doing our job. And then, people would give me stuff and I'd do my analysis and I'd give it back. What this collaboration is about is we're all in the same physical space. And what happens with that is you get this amazing communication throughout the team that wouldn't happen if you were physically separated. And that's why I'm going to push and push and push for you guys to meet your teams as often as possible. If you can face-to-face, that's fine. If you can't, your short meetings, then and they're virtual, that's fine too. Even while you're writing software, you're going to get assignments on your teams and your job is to do such and such a thing. Heck, get on Discord, get on Zoom so you're in the same physical space. And then if you have a problem with software, it's like, hey, you guys mind taking a look at this? Now we know you all have different time constraints, so that's not going to happen all the time, but let it happen as much as you can let it happen, as much as your group can do. And that's the first level of collaboration. Then the next level of collaboration is between you and your management. A good manager does this. A good manager gives all the tools for you that you need to succeed and then gets out of your way. And then every time there's a problem, that good manager will come in and give you what you need to fix the problem and then get out of your way. So there's collaboration there where you're constantly, because it's this incremental approach, you're constantly showing your work. After your sprint, you go back and show your work to the internal management. And then they're going to give you advice and direction, or you get to say to them, hey, here's what we need for the next part of the project. We need another developer, or we need access to a cloud computing system, or whatever. And then the next level of collaboration, which is a large breakthrough, is collaboration with the customer. Ideally, and this rarely happens, ideally the customer would have someone from their company in your team working with you every day. Now, why do you think that doesn't happen really very much? Take a guess.
Can you repeat the question again?
Oh, sure, no problem. Here's my team, my software team, and we all sit in the same room. And then there's a customer, right? The customer, they work for another company and they're paying us. Someone from the customer's team should be sitting in my room every day, basically working with my team. That doesn't happen very much. It's a goal, but it doesn't happen very much. Why do you think that doesn't happen very much? Take a guess.
It's an additional task for that person, maybe to sit in.
Okay, right. And that person has a job, you know, let's say company A hired us to do software. That person has a job at company A, right? And they're paying him or her to do a job. And so it's cost, right? Company A doesn't necessarily see the value in having a rep sitting down here and, you know, babysitting the software developers at our company. And we wouldn't see it as babysitting, we would see it as collaboration. No, we want you to be deeply involved in the product or have someone on your team from company A deeply involved in the product so that you understand our challenges and you understand our point of view. And if we come up with a really cool idea, you know, we can pitch it to you. And if we come up with a really lousy idea, you can tell us that day rather than a month from now when we've already invested all this time in it. So there's a lot of collaboration here. This is about, and we'll see it later, teams and processes and collaboration. And then it says just enough ceremony to promote software quality. Just enough ceremony. Now, what do they mean by that? Remember, engineering as a discipline has a lot of what they're calling ceremony here. It is common in the, say, the physical engineering world. You know, again, when I lived in the engineering industry and we were making things for our customer, we would come up with a design and we would have what's called a preliminary design review. And that was an all-day event, maybe a day and a half event, where 30 members from the customer would fly into our town and we'd all have a meeting of 40 or 50 people, giving them our preliminary design. And then about 3 or 4 months later, they'd come back and we'd have the critical design review, which means that's the final design. And then we would come back and we would actually start making the product and doing tests, and we had to document everything. When I was at NASA, I didn't work for NASA, I worked for Boeing, but I was down at KSC, and they would put a black box, let's say, and mount it to a piece of space flight hardware, and they would tighten the bolts, and those bolts had to be tightened to a certain torque. And there was an inspector watching the tech tighten the bolt. The tech would read off the torque value, the inspector would write the torque value in the book, every bolt. That's a lot of ceremony. And then to make sure the bolts didn't back out, a lot of times they would take metal wire, and the bolts had little holes in the head. You would string the metal wire through, and at the end you would have to curl the metal wire up, and it was called a pigtail. Well, you know, it turns out in space they don't like jagged pieces of wire sticking out of things. So they would take a bit of RTV, like a rubbery compound, and coat the end so that if an astronaut brushed up against it, it wouldn't rip the suit or anything like that. And after they did that, guess what they did? They'd call the photographer, who came in and took picture, 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 all documentation. That's a lot of ceremony. Absolutely justified in a spaceflight environment because the cause of failure was death. But that's a lot of work. Now think about that in a software field. Every time you make a change, you need to have an inspector over your shoulder. Change line 48 of the code, check, right? So what do we mean by just enough ceremony? Well, that's the team gets to decide that in a real world setting. Some teams, the crystal clear process, Virtually no documentation. The code is the documentation. How do they document the design before they do the code? They all go to a whiteboard, they draw pictures, and they take a picture of the whiteboard. I've seen students do that a lot, right? You're not being lazy, you're being agile. So that's the technique here. Incremental, collaborative, just enough documentation where you feel comfortable. Now, different communities have a different idea of how much documentation makes them comfortable. A big company, Microsoft, companies that are selling product to the FAA or the DoD, they're going to have a heavier mindset on documentation than someone who's 6 guys in a garage building an app that's going to go up on the Android Play Store. Your team gets to adapt to that. Now, unfortunately for you, I get to tell you what the level of documentation is. And my goal is to give you enough experience with documentation that you get good at it, and not so much that I'm in your way, right? I want to give you what you need to do the job and get out of your way. So I need to be sure you're following some kind of a process, and yet I don't want to overburden you with documentation because I want you to create software. Okay. Half an hour, I've been through 2 slides. We'll pick up a little bit. Okay, now these guys, this is where the previous slide turns into maxims of Agile. And these are good to have. These are, wouldn't hurt to memorize these things. Individuals and interactions over processes and tools. So I'm giving you the Agile process, and I will enforce the Agile process in this class setting so that you can learn about it. But let's say you're in a club activity after this, or you want to go to the, you want to build a little company or something like that. By giving you this experience of what a generic process looks like, you can then adapt it to your needs. So your individual group and interactions are going to change how you perform the process. So individuals and interactions over processes and tools. Working software over comprehensive documentation. That's why after that first sprint, you have working software. May not do much, but it works. Customer collaboration over contract negotiation. So again, instead of getting that contract up front, you negotiate it, and then the customer kind of leaves you out in the woods while you're developing. You're constantly working with the customer as a collaborator. And if they do require a major change, that's okay. The contract can be renegotiated. You make the expectation up front, and you become, normally you have an oppositional relationship with your customer. You're opponents to some degree. So rather than being opponents, you become collaborators. And then responding to change over following a plan. And why would you do that? Because even if you have a plan, change will happen and you can't stop it. So you may as well respond to it and not try to nail everything down up front. The generals say, everyone has a battle plan until the first shot is fired. And I think, who's the famous boxer, Michael, what's his name? Everyone has a plan until they get punched in the mouth. Same thing. And what are the values? Focus on interaction among the teams. Documentation doesn't execute. It's not the product. If you're delivering, when I say the product, I mean software, real software. Now, I'll bend that a little bit because I'll say software plus documentation is the product. But the actual part that does the job is not the documentation. We should add that user guides are probably helpful, right? But they're not the working software. Making the customer part of the team. Again, get rid of the oppositional relationship and get the collaborative relationship. And then planning is often wasted effort. You can plan and plan and plan, but then as soon as that change comes, all those plans are out the window. And remember, the documentation that you had to use to make sure you were following the plan, as I said, often will be wrong because you changed the software, but you didn't change the documentation. Minimize risk. As engineers, I guess as instructors, we don't talk enough about risk management in engineering. Only certain classes do, but that's part of what this is all about, minimizing risk. Iterations, 1 to 4 weeks, ours are going to be 2 weeks long. So you get 5 sprints of 2 weeks each, 10 weeks. Each iteration is a little project. You have working software at the end, and we'll start, and I'll go through the details of this, but you start out with a planning meeting, and then you go through the actual work, and then you have a post meeting, a reflection and introspection to talk about what did you do and how can you do the next part differently or better. We emphasize real-time communication. All team members are co-located. Now, please think about that now and give me ideas if you can, if you want to. How is your team going to do this co-location thing? What if you have someone who's not on campus? What if you have 2 members on campus, 2 members off campus? How are you going to do that? What is co-located?
Oh.
Yeah, go ahead.
Oh.
Hold on, my dog's barking. Yeah.
I think for me, I will prioritize like Zoom meeting, probably 5-6 minutes per day, or
Right.
Yeah.
Right, and then like I said, even if you're coding, hey, you can throw out a thing to your teammates and say, I'm going to be coding here for the next 2 hours. Here's my Discord, or here's my Zoom. If anybody wants to just sit there, maybe they're watching a movie or something. It doesn't matter. The fact that you're in the same virtual space, you're coding, and then you have a question. Hey, what were we going to do about so-and-so? And you can ask them in real time. This real-time communication is shockingly helpful. And like I said, I'm on a team with 4 people right now, and I'm off campus, and two faculty members are on campus, 2 of us are off campus, and we meet in Zoom. And that being able to be in Zoom, like I said, for an hour where we're actually working and doing this real-time communication, it's really helpful. And if we needed more, we would have set up more. Yeah. So think about that. How are you going to do that? How often are you going to communicate with your team? The problem is, let's say you have a team meeting once a week, which by the way, isn't probably going to work for this process. You have a team meeting once a week, you meet with your team, and then what do you do the rest of the week? No communication, right? You ignore them and you're like, oh God, I got to get my work done before the next meeting. But what you really wanted to have is a check-in every day. That's why I'm going to set you up your own team discussion groups on Canvas, right? Check in every day. Maybe you can upload some of your, even if it's not real time, upload your software and say, hey, I'm having troubles line 38 through 9 through 42. What do you think? That kind of thing. Now, by the way, we're going to use other tools like, GitHub and stuff like that. But I'm saying, start thinking now, how are you going to get this interaction? Because I'm not going to be able to force you to do it or guilt you into doing it. This is something that your teams have to come up with on their own motivations. If we were on campus and we met 3 times a week, or whoops, what happened to chat? There we go. Come on. I'm fighting with Zoom. There we go. All right, chat doesn't come up. All right. If we were meeting 3 times a week, then you would get a lot of your interaction right there. In fact, when I run this class face-to-face, and I know when other professors run this class face-to-face, you meet for 2 hours on Monday, 2 hours on Wednesday face-to-face. And I always did it with the first hour was lecture and the second hour was team meeting for both days. We can't quite do that here online. So instead, I'm giving you just the longer lecture today, and the rest of the week, I'm encouraging you to go meet your teams. Blah, 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 history. Waterfall was the older way where you did all the pre-requirements, all the design, all the development, all the testing. I've heard it called throw it over the wall, right? I did my part, I throw it over the wall to the next person who has to do their part. And then Agile is a little bit more back to this not so regimented, smaller incremental cycles. Oh, let's see here. Let's run through these quick. Customer satisfaction by 2 weeks, continuous delivery of useful software. And again, they get to see that you're doing something, and if there's something they don't like, they get to stop it immediately, not towards the end. You get to respond to changes. Working software is your principal measure of progress, and we're going to have charts that show, okay, they're called burn down charts, right? That show how much progress you're making. Late changes, I wouldn't say welcomed, but they're at least not offensive. Daily conversations. Project built around motivated individuals. That's you guys, right? I can't coerce this. You have to have your team self-motivated. We'll talk about teaming next week too. Self-organizing teams. Okay, I'm going to assign you to teams, but you get to organize yourself to a degree. I've already gone through all this slide, actually. The predictive methods we're saying we're going to plan everything out and nail it down and predict how things are going to go. And of course, it never works. And the adaptive are more, we're going to see how things go, and as they change, we'll adapt to them. Now, this iterative, see, there's only really one thing. That there are iterative techniques. Towards the end of the semester, I'm going to talk about several different software development paradigms, one of which is like the spiral method. The spiral method is you keep, here's where you are at the top. You hit this milestone and you have working software, and then you come around to another period of time and you have working software, but it does more. And it's called spiral because every time you go around the loop, you're adding more capability. So that's that's an example of an iterative technique. So that portion of doing your software builds and iterations is not unique to the Agile techniques. What's unique to it is the time frame, number one, is much shorter, and time frame is strict. So here's one good thing about Agile. Let's say, remember in the first thing I said, oh gosh, most software is like 180% of schedule, of planned schedule. So, it's supposed to be done in 10 months, it was done in 18 months. Oh, and it was supposed to be $100,000 and it was $180,000. Agile actually gets rid of that. And it does it this way. It says, we need to have 100 features that we've identified with the software. There's 100 features. And of those 100 features, 70 of them are needed. And the other 30 are really nice to have. But if you just deliver the product with those 70, then we're going to agree that that's a functioning product. So we're going to shoot for all 100. And so you do your 2 weeks, 2 weeks, 2 weeks, 2 weeks, 2 weeks. Eventually time runs out. And what happens when time runs out? You look at what you did and you said, well, we got 80 of them. The other 20, we're just not going to do. So the time frame is strict. This helps a lot as long as you get your work done. This helps a lot because it gets rid of that problem where software deliveries kept getting delayed and delayed and delayed. Software is never done, and people always want to modify it. So it gets rid of that problem. Now, obviously, it introduces a different problem. What if you don't get enough of those features completed? Well, you're not going to get paid. That's the problem. But if you're developing this thing appropriately and you've got fairly good estimation techniques, then you're not going to fall into that trap. Compared with waterfall. So we haven't really talked about what waterfall is, but waterfall is the requirements, design, build, test, deploy, right? All in a forward-driven fashion. And so this is just comparing with Agile, which I think I've already done in my talking a while ago, so I'm not going to spend a lot of time on this chart. Agile contrasted with cowboy. Now, this is actually an important chart. Whenever you hear someone and you say, oh, what's your process? And they say Agile, you have to be careful, because there was a good 5-year period of time around the year 2000. In the 90s, Agile was being invented. So let's say 95, just to pick a day. And by 2000, it was really popular. And so people were saying, oh, what's your software process? we do Agile. And what they meant was they had no process. Agile means you can do whatever you want, right? No. Agile means I don't have to document anything. Not necessarily, no. So people were confusing no process with Agile. And in this class, you know, I'm going to force some structure on you with the process I want you to follow, only because, and you'll see this in a chart later on, I think, Agile does work best with people who have had some experience and can make their own decisions about what's going to work and not going to work for a specific product or a specific team or a specific environment or a specific customer. So the cowboy coding, this is the historical way that we do programming in academia. We do research projects and the software is hideous, not reusable. Nobody knows the design. Why? Because we just went in and started coding some stuff up. So be clear again, and then, you know, let's say when you're getting a chance to be an intern or a hired at a small startup company, be a little careful about their process and make sure that it truly is Agile and not no process. And there's the line, the third one down, requires higher competence. So it doesn't mean you don't necessarily need competence in different areas, but you need competence within this process. And of course, you know, the software developers themselves need some experience. It's not, this is not the best process if you've never programmed before to just throw at you and say, hey, do Agile. Now, in this class, you guys have all programmed some, and you're starting to be hopefully more comfortable with larger and sophisticated, more sophisticated software projects. But even then, I wouldn't just throw you to the wolves. That's why I'm enforcing some of the process on you, to give you an expectation of what to expect and what to do, and you know what your actual tasks are from week to week. And you know, you need to know if you feel comfortable that you're going to get a good grade in the course or not too, right? So. Notice this one, the fourth one down, organizations must live with the decisions developers make. That is 180 degrees out from how organizations often want to work. The boss wants to tell the developers what to do. The boss doesn't want the developers telling them how they're going to do it. But this is saying, no, you push that, right? If you've got good people, you can push that decision-making down, and it's probably going to be a good decision and probably going to be a better decision, because the people who had to carry it out are the ones making the decision. The people who are most intimately familiar with the problem and the product and hopefully the customer are the ones who are actually making the decision. Whereas the higher up you go in management chain, the more removed you are from the reality of a project. Suitable for projects with small teams, fewer than 20 to 40 people, and most are smaller than that. You know, an Agile Scrum team, 7, 8, 9 people, you know, 4 people is good. That's what we'll have in this class, but 7, 8, 9 people. I think if we had like teams of 8 in this class, that'd be too many for the class. So that's why 4, and I'm going to have one team at 5 because I got an extra person. We were at 48 in the class, which I was like so happy because that's 12 teams of 4, and then 49. Agile versus plan driven. The plan is, well, what do they mean by low criticality? They mean like safety, or you know, people die. That's changing. That's changing. It used to be Agile was only for low criticality stuff. Oh man, this app on my phone stopped working. What a bummer. But nobody died, right? No buildings caught on fire because of that. So that's what we mean by low criticality. And the planned criticality, the plan driven was more for safety things. So that's why, you know, the last people who started to adopt Agile processes were DoD and FAA and NASA. You know, these are people who are dealing in places where you cannot have failure. You know, the FAA has bad software. You know, a jumbo liner goes down with 500 dead people and you're on the news, and you know, look what happened to Boeing stock after the 737 debacles. You know, this stuff matters. And that was a software problem and a human factors problem. And a, and a corrupt Boeing government agency relationship problem. So low criticality, but I'll tell you, that's changing. FAA is getting interested in Agile, and people are trying to figure out, how can I take Agile? Remember, small teams is what it was originally developed for. How can I take Agile and turn it into large teams, 300 software developers on a team? And the way you do that is recursively. You have small teams that then have a member that reports to another small team higher up, but because that team is representative of 4 or 5 other small teams, you can keep building up, kind of like a management chain. Teams of teams. So people are figuring that out. Now, why are they doing that? Because there's been a lot of success in the commercial world with Agile stuff. So we're getting into, how do you adapt? You know, the FAA and the DoD and NASA and these other people that deal in medical communities, dealing with highly critical software, they're trying to figure out, how do I take this Agile stuff that worked for these small people, bring them into my organization that has a lot of people, so I can be Agile and yet still retain the high quality assurance that I had before. And that's why that slide that was second slide in, remember it said enough ceremony to maintain the quality of software. Well, the ceremony is going to be different, higher at the FAA level than probably, I assume, like Assassin's Creed kind of developers. Senior developers versus junior developers, but that can be fixed by prescribing the process for the junior developers, as we're doing here. Requirements change very often versus low requirements change. Well, the problem with that low requirements change is that often doesn't happen, and sometimes it only takes one requirements change to blow everything out of the water. Culture that thrives on chaos versus a culture that demands order. I think chaos is an interesting word choice. Again, I didn't write these slides. I think chaos is an interesting word choice. Maybe culture that thrives on dynamism, something like that. Okay, but as we said, there's no magic bullet. That's the name of Fred Brooks' book about software development, No Magic Bullet. So what are the issues? Well, let's see. Since you initially want to get that software working, you may lock yourself into a poor architecture. You remember, the thing with the waterfall method is you get a complete design before you start doing any serious coding, or really any coding. And here what you're doing is you're getting a conceptual design, a skeletal design, and then you start coding. And if you go too far down the line, you might find that your initial guesses as to what the architecture should look like is bad. And now you're stuck with it. Client may be talked into poor choices by developer. It can happen. And this single dominant developer may exert undue influence. This is a problem actually in class settings. You know, in EGR 101, we had teams of 3. I only taught that one semester, but we had teams of 3. And there was one person who was like, you know, all through high school, his hobby was just programming. And the other people on the team, that wasn't their hobby. And this person was constantly just trying to take the code over. And I really had to fight that. I mean, I really had to say, literally say, you are not allowed to touch the computer today. The other people have to do some programming, you know, so that they could get some semblance of a team dynamic. If you see that happening in your team, you may think, oh, thank God, that other person's doing all the coding. That's great. But I would urge you not to have that thought, and instead think, oh crap, I'm not going to learn anything from this class if one person in my team is doing all the work. And it may turn out that my grade suffers too, because you know my lab, my instructor and my tutorial people are seeing that I'm not contributing that much. You really want to try to get team decisions. And then this depends on the ability of the customer. Remember I said, ideally you would have a customer rep right embedded with you, and that's not going to happen. They're not going to spend that money. So the next best thing is to have rapid turnaround with the customer. But then you say, hey, I want to do this development. And instead of having the actual customer team show up to give you good feedback, they just send some, you know, poor guy who just got hired and doesn't know what's going on. So, you really have to, the collaboration works both ways. The customer isn't always going to be thrilled to talk to you because they got stuff to do too. And they think, oh man, I paid you to do that, right? I paid you to stay out of my hair. And you really need to have an understanding with the customer. No, you paid me to collaborate with you. So fortunately for you, the tutors for the course, I will strongly encourage them to be collaborative customers for your teams so that they need to kind of really understand your team dynamics. And with 6 teams per, that's right on the boundary of feasibility here, right? It's going to be hard for them to keep up with 6 teams. Impossible for me to keep up with 12. Lack of structure and necessary documentation. And there is a religious war about that. Some say documentation is no good anyway. Who cares? And some people say, no, you need documentation for maintainability issues, for quality issues. Only works with senior level developers. I think that senior level can be a rubbery term there. So it is true, or I do believe, I should say, that the more experience you have in software, the more you can work in a less restrictive environment. And that's true pretty much in any discipline, I think. Insufficient software design. Yeah, you may have adequate software and not great software. Again, because you had to do some decision making early on that affected the decision making later on, where maybe you didn't have enough information early on to make the best decision. But as long as you make an adequate decision, you've really met the goal of the customer, haven't you? Requires too much cultural change to adopt. That used to be true, and that is absolutely true. In terms of like the Boeings and the Lockheeds. We've been doing it this way for 30 years. Who are you to tell me to do it differently? Oh, that's fine for you, but it won't work for me. That kind of technical arrogance shows up a lot. But as I said, that is changing. That is changing because people are seeing the success of Agile. And so people are asking the question instead, the Boeings and the Lockheeds are asking instead, how can I adapt this practice to my business model? We're not going to completely shatter our culture, but we're going to modify it to introduce these Agile concepts. Contractual negotiations, yeah, because you might be telling the customer, look, this is our initial contract, but expect us to be, just like we're continuously evolving the product, maybe continuously doing checks on that contract and doing change orders. Oh, by the way, in a large contract anyway, you're always doing change orders. And in fact, that is sometimes used unethically by companies. I remember the Tomahawk missile contract used to go to General Dynamics, and then it would go to McDonnell Douglas, and then it would go to General Dynamics. And every 2 years it swapped out back and forth. And the reason is the company that wasn't making it would come in and say, I can make it really cheap. And so the government would give the contract to them. And then once they got the contract, I'm not sure if it was ethical or not because I wasn't on that program, but magically they would say, we have a contract change order and now they're not so cheap anymore. Companies do that unethically sometimes, where they buy into a contract cheap, and then the first change down the road, they're like, okay, change order, time to get well. So just be aware that that's out there. Don't do that. Don't be unethical. Here's a bunch of different Agile software development methods. We're going to do Scrum. Extreme programming is just program. Crystal clear is kind of a mix with, like I said, there's very little documentation. The Agile Scrum seems to be the most popular one, and there's a big culture around it now. You literally can get Scrum certified and be a certified Scrum Master. So you can take your ticket to some company and ask them to hire you. You can become a certified Scrum trainer and make your living by training other people to do this. So it's a big culture out there now. Okay, that's the end of part 1. Do we have a discussion about Agile development methods in general? Questions? Wake up. Do something. Get up and stretch for a minute so you don't fall asleep. I've been talking at you for an hour. No questions, comments? Yeah, go ahead.
Oh, am I coming out?
Yep, Nicholas, is
I'm
that,
getting that green square. So,
I hear you. I hear
No.
somebody.
so you were saying earlier the meetings that you wanted us to have with our groups, these are going to be Scrum meetings, or can it just be like whatever kind of meeting works?
I'm going to prescribe that you have at the beginning of each sprint, there are certain sprint activities and artifacts that I'm going to say, thou shalt. Now, if your team can convince me that for your team and your situation, these can be modified a little bit, and I can incorporate in the grading in a fair way so that, everyone's still being on the level playing field, then we can talk about that. But it's going to be a hard sell. So, and we'll talk about what the different meetings are in this next section. Yeah. Now, I think the biggest flexibility you have is ideally you would have a Scrum meeting every day. I mean, that's the goal. But that's for people who this is my job for 8 or 10 hours a day, and therefore I have time to devote to that. Whereas, for students and faculty, it's a lot different because this is your job for 2 hours on Monday, right? For a 4-credit course, this is your job for 4 credits out of your 15 or 16 credit workload or your 18 credit workload, plus your maybe sports obligation or ROTC obligation or work obligation, right? So I can't say, oh, you must meet every day because you're not devoted to that. But if you can come back and say, oh, our team has decided that we can meet every Wednesday at 3 for an hour, and we can meet 2 other times a week for 20 minutes or 15 minutes as check-ins, and we're also going to keep up a running message board. That meets the intent. You can be flexible about how that happens. That answer the question?
Perfectly. Yeah. Thank you.
Okay.
I have another question too. So,
Sure.
So like when you want to determine if there's a problem and you're trying to make changes to make it better for the product, like software for the projects, so you want to document it and then talk to the team in the meeting before you change it, or what the Agile Scrum do like after the
Right. So that's actually something that would be perfectly addressed within your team, and you can come up with how your team wants to handle those situations. So I'm noticing in the previous semesters they were using GitHub. We'll probably use GitHub again here. So if you're doing software and you're doing your piece of software, you're going to check out the software. Normally there's version control issues that you have to deal with. Check out the software, modify it, check it back in. And your team gets to determine how they want to do that would work best for your team. Now, let's say you have a problem with some software, you check it out, you modify it, or you add to it, and it won't compile locally. You probably don't want to check that back in to the mainline code. So you're going to maybe come up with some process by which your team can work through that. And it might be that you have a special message board or something like that, or a text alert system or something where you say, I've got a problem, and however your team works with that. I wouldn't wait, if you find that you have a problem that's stopping your work, then I wouldn't wait like 2 days for the next meeting. I would find some mechanism that your team agrees on by which you can immediately say, I'm having a problem and it's stopping my work.
Okay.
Whatever that mechanism is up to your team. Does that help? By the way,
Yes.
that's the whole point of the daily Scrum meeting. The daily Scrum meeting, basically you walk in and you say, here's what I did yesterday, here's what I want to do today, and here's what's stopping me from getting my job done. And that's why it's a short meeting. Everybody does that quickly. And then if there's any issues like, okay, here's what's stopping me from getting my job done, and that needs some discussion, then that's going to be the larger part of the meeting. But the whole point is just for everybody to check in and know where they are. And again, I'm not requiring that you meet every day. I don't think it's possible. It's not feasible in a class like this. Other questions?
Professor?
Yeah.
I was wondering, was the spiral method, was it falling under Agile or is it its own
No,
category?
it actually fell more under what they were calling the iterative techniques.
Okay.
The reason it's not Agile is, one reason was that the time frames were far too long to be Agile.
Okay. Thank you.
Yeah. And there wasn't the other component of teams co-located with osmotic communication or anything like that. These are good questions. Keep them coming.
Professor, have you heard of the Agile board game?
Oh, I don't think I have, but for some reason my brain isn't saying no completely. I know I've never seen it. Yeah.
It exists, it's real, and it's actually kind of fun.
And is its goal to teach the Agile process, or is it just completely divorced
Yeah, it's to teach the Agile process. We did it at one of my first internships so that all us
Okay.
interns could figure stuff out.
I have done mock Agile processes that were in a game-like atmosphere, but I've not played the board game. This is a big community, so what do you know? People are making board games.
Yeah, and if you wanted to, I think you can just like print out pieces of paper and then laminate it. Although it actually requires like game pieces or whatever.
Yeah, we should
But
look
yeah.
for it. Check the licensing, right? Yeah. B-O-A-R-D, not B-O-R-E-D. Okay. Other questions, comments? Okay. Again, 49 people in class and 19 of you here. So if you know people who are in this class who don't seem to be on this, just shoot them a message that maybe they should watch the video or quiz them about what they're doing. I don't like, no, I'm not going to say that. These charts are okay, but I want to create a chart for you that summarizes this in a little bit different form. This is supposed to show you the basic process of one sprint. So you have this thing called a product backlog, and basically that's a list of tasks or a list of features that need to be completed. And we have a couple different, let's see where to start. We have a couple different roles here. We have somebody called a product owner, we have someone called a scrum master, and then we have the development team. In our group, and the product owner is normally not part of the development team, but in our groups they will be. So I'll designate one of you guys a product owner. Once you do your product owner job, you still participate as part of the team. I want to rotate those positions throughout the semester so everybody gets an opportunity to play these roles. But you start out, let's see, the whole process of a product here. Let's see, the customer is going to come to you with some requirements, and you do requirement solicitation. These are not requirements specifications in the way we talked about testing in previous semesters. These are just, you try to identify everything that the product is supposed to be doing. And then from there, you can create itemized backlog items, which are often in the form of user story, what are called user stories. I want the product to do this. I want the product to do this. I want the product to do that. And sometimes you have user stories like, we need to make a schedule, or we need to, we need to do some other task before we can start. So that's why sometimes the first sprint is not product, getting that software product out the door. It's like a pre-sprint sprint. And that's what I'm asking you guys to try to get done during your team formation week, your product definition week, prior to the sprint starting. So product backlog, and now the product owner is the one who gets to prioritize these. And the rule is every item that's on the list, the backlog is everything we have to do, and every item that's on that list gets a priority, and there can't be any matching priorities. And then basically what you're doing is taking these priorities, and the first priority gets assigned first, second priority gets assigned next, third one gets assigned next, and you take these and move these into the sprint backlog. So you have the product backlog, which is everything we're going to do. And then the product owner chunks those out and says, okay, for this one sprint, we can do this. And then the that goes over to the team. And the teams then expands those things into smaller tasks and assigns, and I shouldn't say assign, you actually volunteer. Oh, I'll do that task, I'll do that task, I'll do that task. And all of these are filled up with should be filled up with estimates of effort. Now, I'm going to ask you guys to use hours of time as effort estimates. Other people do like a point system, like Scrum points or something like that. But I'm going to ask you to do hours. So the idea is, you should know each week on this class, okay, on this class, I know I can devote 8 hours a week to this class. And I'm going to eat up 2 of those in lecture and 2 for an assignment. So I've got 4 more hours to actually work with product. And so that's, I'm going to accept 4 hours worth of task for each sprint. You guys have to work that out. Once those tasks are accepted by the development team, you freeze everything for a week for your 2-week sprint. You meet as often as you can, you perform work, and then at the end you've got a working product. It's not a completed product, but a working product. Then at the end, Buddha has something to say. You know him. At the end, you have to then look back at the last 2 weeks and say, okay, what worked and what didn't. You assess where the backlog is, and you are looking at things that aren't done that get thrown back into the hopper of the product backlog. And you're going to do a sprint retrospection where you're talking, okay, what worked, what didn't, what do we need to do differently? That kind of thing. Then you start off the next. Again, the product owner is saying, here's what goes in the next sprint. You have a sprint organizational meeting again. You're breaking things up into tasks, volunteering to take on tasks, going through the work. And now you've got a product that is more functional. At some point, you're going to reach what we would call a minimally viable product. Minimally viable product is basically what's the least amount of functionality that the customer would actually say, okay, you met my goals. You met my minimal goals, I should say. So that's the process that happens over and over and over again. What are the artifacts? Product backlog, sprint backlog, burn down charts. I'm also going to ask you guys to do some minimal documentation of your retrospective meetings. Hey, what have we learned? What are we modifying? So I can see that your team is going through growth. And all of these things, though, if you notice, all of these things are about product. There's no requirements, there's no tests, there's no software design. This is all about the product itself. What are the tasks? Product backlog. What are the things we still need to do for the product? Sprint backlog. What are the things we want to do this sprint? Burn down charts. How well did we do? Again, product, it's a product, so it's the whole project. And it's prioritized by the product owner. So the product owner, you guys can have as many fights as you want about that. You think something should be higher priority than the product owner does. And you can argue and argue and argue. At the end of the day, the product owner gets to say, I still think this is the right sequence of priorities. You can reprioritize at the start of the sprint, but once that sprint starts, you're kind of frozen there for a while. And it says requirements of the system. I also think of it as this is just tasks we have to do, because some of the tasks are really overhead tasks. They're not necessarily related to functioning product, but you can't do them until you get to functioning product. You might need to do some research on something before you can do the work on the product. List of user stories is how we'll do ours, and the user story is, and then they say story points. I'm going to request that you do hours of effort. So each line item is going to be a user story, which is, as a blank, I want to blank. As a administrator, I want to be able to create new accounts. As an administrator, I want to be able to delete accounts. These are all user stories. And then the user story will have an effort. I think that's going to take 4 hours worth of coding, and then a priority. And again, those of you that took CS225 with me, if you remember, last semester I really started that format. But I had you guys do user stories before, but last semester I really had you lay out just a simple chart. Here's my user stories. Here's my effort that I think each one will take. Here's my priority. And I did that to give you experience for this class. Okay. These are pretty straightforward. We'll talk more about these, but basically it's as a user, I want to, as a blank, I want to, so I can. And if the so I can is sometimes optional, as a user, I want to, but it's the why I consider optional, but nice to have. It puts context into this thing. Now, here's the thing about user stories, though. Let's go through this quickly. I'm going to come back to this. Here's the thing about user stories. When you create a user story, your team has to agree on what it means to be done with that user story. So this is why when you start the sprint and you have a sprint planning meeting and you say, okay, we've already got we're creating user stories. You can either agree here, this is what it means to be done, or when that user story gets put into the product backlog. Usually, you're going to have an initial meeting where you say, okay, these are the project requirements, not requirement specifications. I'm going to make distinguishing in those terms this semester. The requirements are just generalized. This is what the product has to do. You try to capture as many of those as you can up front, and then you start doing user stories from those. Okay, as a programmer, I want to blank so I can perform testing. As a user, I want to da 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 da. When you make that user story, you're going to make your effort estimate and you're going to make your priorities. Now, those can change, right? Those can change over time, but you make your initial ones. At that time, you can say, as a group, we all have to agree what it means to be done with that user story, the definition of done. It might mean that you have to pass a bunch of tests. It might mean, usually you can identify it in some kind of a more informal way. Then when you get the user story, the product owner says, okay, this sprint, this is what we're going to do. And, the Scrum Master team and developer then lay out those tasks. If you were assigned or you volunteered for, I should say, a particular user story, at the end of your sprint, you would like to say, I got my user story done, it's done. Well, that's where this definition of done comes in. I think it's a critical thing that it's hard, it's easy to overlook, I think. But basically, when you say you're done with a user story, what that should mean is you never have to touch it again. And that means that everybody has to agree, yeah, it really did do what we thought it was going to do. Now, that's a lot of work, by the way, sometimes to get that agreement among 4 people. However, look at all the communication that has to happen among the team. Look at the shared situational awareness that has to happen among the team in order to come to that agreement. So there is value in that. Okay. Efforts. I'm gonna ask you to just estimate hours, and you're not on the hook for that. You might find that you estimated some hours for a user story. You did another user story, and it turns out you realized it made the other one a lot easier. You could go back after the sprint. You can't do this in the middle of a sprint. After the sprint, and you can, knock it down, or you may knock it up. You might raise it higher. It is also common after a sprint, you might actually add items to the product backlog. The product backlog starts out this big. It doesn't always go down. sometimes you're like, oh, wait, now we have to do these other things. Okay, it goes up again, and then it goes down, you know, as you work them off. So the product backlog, it can change size and it can get bigger. And it's not uncommon for it to get bigger at least once during your process, because you're going to learn more about the product as you start to flesh it out. And so you have more detail about the kinds of things you can do. How big should a user story be? How many hours of work should a user story be? I don't care. Your team can decide on that. I wouldn't want a user story to be 30 hours of work, because that probably means you've got 5 or 6 or 8 user stories inside there. You know, a 2-hour, 4-hour, 8-hour, those I think would be reasonable, but your team can decide that. If you come to me with a user story of 30 hours, I'm probably not going to say, thou shalt not, but I'll probably say, boy, you're going to have trouble with that, right? You're going to have some interesting times with that. So here's a possibility, and these are estimates. And again, I think just estimate in terms of time hours that you think, just because it maps so easily to your scheduling. The team must work on sprints popular stories. Yeah, any team member can add, delete, or change the sprint backlog, but remember the sprint backlog is different from the product backlog. The product backlog, the product owner is in charge of. The sprint backlog, that's when you're, that belongs to the team. So that's where you can get some flexibility in real time. Okay. I don't care about that. Burn down charts. How do you keep track of this stuff? What you can do, or what you should do, I want these graphical forms work out well. So basically, this is not too bad. What I'm not seeing on any of these burn down charts is here's no progress, here's too little progress, here's too slow, too fast to progress. I want to rework these, because what should happen here, if you have a burn down chart for a sprint and it's a 2-week sprint, and let's say you added up all the hours that you think all the user stories are going to take, and it's 50 hours, then what you can do is take 50 hours on the beginning of the sprint and draw literally a straight line to 0 hours at the end of the sprint. And then what you should do every time you meet, could be every day, maybe you guys all check in every day, maybe it's every other day, then you're going to update the burn down chart. And if the straight line is just average progress, and if you find that your team is above the straight line, then it means you're not making enough progress. And if it goes below the straight line, then you're making good progress. But here's one thing that's interesting. If you notice, what's being tracked is hours left to work. Usually people track how many hours they did work, but here you're always tracking hours left to work. And you're not really tracking items left to do. The thing that's important is to track hours left to work. And why is that? Because remember, one of the features of the Agile system was the time constraint is fixed. So in 2 weeks, whatever you got done is what you got done. And you can't say, hey, can we extend this sprint by 3 days so we can get something else done? No, it's time boxed. This is actually a great tool. It forces you to get your work done as efficiently as you can. And also at the end of the semester, we're done, right? You might have stuff in your product backlog still, but as long as we agree on what minimally viable product looks like, then those things that are in your backlog that are not completed are fine. And again, it stops this whole thing where software that should have taken a year took 2 years. Instead, it took a year and we got 90% of our functionality instead of 100% of our functionality. Because we all know the old saying, the first 90% of the work takes the first 90% of the time, and the last 10% of the work takes the other 90% of the time. So instead, time box this stuff. So I'm going to ask you guys to keep product backlog, sprint backlog, burn down charts, and some fairly minimal notion of the, what did you learn in the sprint retrospective, that kind of thing. So I'll keep you to those fairly simple documents. Now I will ask, I'm adding to the Agile here by having you build up as you go a software design document and a sprint a requirements and test document. And the reason is those are both good documents to know how to build, because those are things that are commonly used in real world software projects. Even with Agile being as popular as it is, even with Agile people saying working software is more important than documentation, large corporations will not, and I believe cannot, for valid reasons, let go of software design documents and requirements and test documents. So we'll have you build those up too. Okay, so I'm going to leave that up to the team, how you want to build those. I suspect those should be built incrementally as you go through your sprints, not try to design everything at once, because if you do that, you're really not following the Agile process. I would recommend that you get a good schematic of what you think things are going to be up front, but not a detailed design. Okay. That pulls us through. See, these are the charts I did to this part. I'm going to do this 3 and 4 next week, because again, it's been an hour and a half. Why you guys aren't all, maybe you guys are all sleeping. Why you're not sleeping is beyond me. Any questions or comments? One last thing before we go. 2 last things before we go. There it is. I posted this online. This is the Bible. I believe there's an update, and I don't have the update, but we'll use this. We'll freeze ourselves at 2017. This thing is telling you about the same stuff I told you in the notes, but with fuller descriptions. Tells you specifically what the roles are and who's responsible for what and what the events are. So between this and my lectures and the notes and guidance that we give, that's the expectation for following the processes. One more thing with that Scrum guide. Oh yeah, and I'm going to add some slides that hopefully summarize the process of the whole product development and each sprint cycle in a summarized form, and then you can go back and if you use that as a guide and fill out the details with that Scrum guide. Please read that Scrum guide. Take it to heart. It's a good thing. It's well written too. It's an easy read. Questions?
I think I'm good.
Okay. All right. Thanks for being here. Please spread the word to people that you know are in this class that are not attending the live lecture. Encourage them to read the Scrum guide as a minimum, and encourage them to look at the notes as the next to minimum. So Scrum guide and notes is the minimally viable product here. And then if they want to watch this video, please do. Okay. Thanks, guys. We really appreciate you being here. I appreciate the questions and comments too.
Thank you very much, Professor.
Have a good one.
Thanks. Have a good one.